Good evening all of you. Audio video clear, please respond. So welcome all of you. Today we are discussing a very important or very interesting or a topic that many people are afraid of. Such a topic we are discussing, probability. Last classes we discussed about permutation combination. Some of the ideas used there is needed here also. So those if you missed those session, after this session you can check out the recording of those sessions also. So probability is a topic, and those of you want printed study material for CSIR-NET Part A, this is the printed study material which is currently the bestseller book we have written for CSIR-NET, General Aptitude and other playlists. Especially if you are preparing for GATE, complete free course on GATE is available in our channel, and there is CSIR-NET previous year question full playlist is there. Last few years previous year question detailed discussion playlist is available, and other full course available in this channel also you can refer. So all these are free study materials we are providing for CSIR-NET, GATE and other exams also. If you are a UPSC, CSAT, for preparing for UPSC, CSAT, if you want materials, that is also available, and speed maths or Vedic math lectures are also available in this channel. Refer these videos for those people who want to learn more. Use this video and share it to them also. And if you want to be part of our free resources, you can be part of it by clicking the links in the description, or by scanning this QR code, or by following these procedure. So let us start today's session. As I told in permutation combination chapter we discussed about fundamental principle of counting multiplication rule. That idea is very important in this chapter also. The idea was, if one thing can be done in m ways, another thing in n ways, both the thing together can be done in m into n ways, and m ways, n ways, this or that can be done m plus n ways. Or simply speaking, we can summarize these two rules as and means multiplication or means addition, and means multiplication or means additions. Okay, so there are a lot of things in real life that we seek chances of. We want to find the chance of. So if you want to make probability simple, what I can suggest you is just replace the word probability by chance. For example, what are the chances that it will rain today? So there we are seeking for a chance, right? How much chance is there, or how much probability is there, or what are the chances that I will sleep during this class? So that is again probability itself. What I am trying to say is, don't consider probability as a very crude or very dry mathematical topic. Consider it as a daily life thing that we need to find the chances of something. What are the chances that we will win the toss? For example, India, Australia, T20. We want to guess what is the chance that the Indian captain will win the toss. So again, that is probability. So there are a lot of things that we are seeking chances of. In the case of coin, what are the chances, or what are the things that can occur? When you toss, you will get either a head or a tail. That are called possible outcomes. Possible outcomes are head or tail only. And out of that, if you want to know what is the chance of head, one chance out of two chances, because total there are only two things, head or tail. Again, just familiarizing with the terms in this chapter. Head or tail are the chances means head, tail are called the sample space. Sample space means what all are the things that can happen. What all occurrences are there, that are called sample space. And events means if we are choosing one or two or any number of elements from sample space, that will make an event. For example, what is the probability of getting a head means getting a head, that is called the event there. Or when you toss two coins, what is the probability that you will get at least one head? So at least one head is the event there. So when you, in the case of rolling a dice, 1, 2, 3, 4, 5, 6 are the 6 things that can happen. Rolling a dice means when you play snake and ladder and ludo, the dice that you are using, right? When you roll it, you will either get a 1 or 2 or 3 or 4 or 5 or 6. That means that is a sample space. All possible outcomes are called sample space. And in this case, some of the examples of events are odd number occurring, that is an example of an event. Even number occurring, that is an example of an event. Prime number occurring, that is an example of an event. So I hope all of you are clear with the terminology, sample space, events, etc. So as I told, probability is nothing but chances. We are searching for chances of something to happen or something to not happen also. So that way, if you understand probability, it is very simple. Now you can express this like this using the mathematical definition of probability, or the classical definition of probability. We can say number of outcomes in event E divided by number of all possible outcomes, or in simple terms we can say required number divided by total number. Required number divided by total number. That means total what all can occur, that number, and what we need, what are the occurrences of that. This, if you take the ratio of, that is called probability. Let us take example of tossing the coin itself. Sample space is head and tail. So getting a head means one occurrence out of total 2 occurrence. So 1 by 2 is the probability. Very simple, right? All of you clear or not? I know most of you are already clear about this, but I am just starting from the very base things so that you will not have any confusion in the future. We will focus mainly on theory itself today. For questions, you can check out the other lectures I have provided on this topic. Many lectures I have provided in this channel on probability. In the GATE playlist also you can see probability topic discussed. CSIR-NET other complete course also we have taken lecture on probability. Go through that, you can see more practice questions there. So when you roll a dice, for example, if the event is getting an even number, even numbers in 1, 2, 3, 4, 5, 6 are 2, 4 and 6 now. 2, 4 and 6. So that is 3 occurrences out of total 6 occurrences. So required outcome is 3, total outcome is 6. So 3 by 6 or 1 by 2 is the answer. Matthew knows I am not exactly sure whether it is 6-sided dice itself used in Mahabharat, but it is similar to that, because that, I think, by my understanding, it is not exactly like the dice we use, but it is similar, we can say. Or anyone else know more about it, you can mention in the comments or chat about the dice used in ancient times, or dice used in our in historic times, the dice used, because there are many types of dices. That is a point. So 6-sided dice are also there, even more than 6-sided dice are also there. We don't see that more often because that is very complicated, or that is that is not needed to play simple games like Ludo or Snake and Ladder. But many other types of dices are there. Okay, anyway, so this is clear, I guess, the example of how to find probability of an event. So when you toss 2 coins, what all can occur? When you toss 2 coins, either both will be head, or the first one head, second one head, tail, or first one tail, second one head, or both tails. So this is called the sample space. Head, 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 tail, tail, head, tail, tail. For example, if the question is asking getting at least 1 head, getting at least 1 head means 1 or more than 1 head. 1 or more than 1. That means maximum 2 only is possible, because 2 times only the tossing is done here. So 1 or more than 1 means you can say head tail is okay, tail head is okay, head head is okay. So this is the required outcome. 3 outcomes are there which are required. Total outcome is 4 already, so 3 by 4. All of you understood this? So now let me extend this idea further. Here actually, if the question was asking what is the probability of getting at least 1 head, this could have been done in another way also. Getting at least 1 head means this, all these 3 are okay, right? What is the only thing we don't want? Tail, tail. This is the only thing that is not needed. So by using this also you can do this question faster. That is called complement probability idea. We will discuss about complement events in some time, but I will briefly discuss about that here itself. So the only thing we don't want is tail, tail. That is 1 out of 4 occurrence we don't need. Total 4 occurrence. 1 of this out of this 4 we don't need. All the rest we need. Total probability is always 1. Probability is defined out of 1. Like percentage is defined out of 100, probability is defined out of 1. Like when you toss a single coin, probability of getting head is 1 by 2, or we can say it is 50%. So in percentage we say out of 100 it is 50, out of 2 it is 1. Or probability, total probability of all events added together will be 1. That is why 1 minus 1 by 4 if you do also you will get the answer. This is called complement probability idea. I will get into that also, but when I just explained about getting at least one head, I just mentioned that instead of writing these 3 probability or events, you could have just told the only thing we don't need is getting 0 tail. Sorry, getting 0 head. Getting 0 head means both tail. That 1 out of 4 probability you subtract from total. So you will get 3 out of 4 probability. That is the answer. Okay, so some properties of probability we will discuss. As I told, total probability will be 1. Total probability will be 1 and probability will be between 0 to 1. Probability of anything to happen will be between 0 and 1. It will not be above 1, it will not be below 0. Yeah, sometimes we say to exaggerate things, we say after exam if someone asks you how was the exam, will you clear it, you will say it is 200% sure I will clear. You cannot be 200% sure, you can maximum be 100% sure. Same way probability can be maximum 1 only. Probability of something to happen can be 1, that is called a sure event. Sure event means there is no other chance not to happen, it will surely happen. That events are called sure events, or that event's probability is 1. And probability of something is 0 means it is impossible event. Impossible means that will never happen, there is no chance for that to happen. So it cannot go below 0, na? For the probability cannot go below 0, it cannot go above 1. So that is called probability line. Minimum probability is 0, maximum probability is 1. All other probabilities will be between that. So if probability of something is half means the chances that it will happen and chances that it will not happen are equal, or we can say even chance. Because half chance for it to happen, 1 minus half chance for it to not happen. Total probability is 1 now. And number line you can elaborate little bit more here. Impossible event means 0 probability. Certain event or sure event means 1 probability. I will tell you an example of a certain event. When you toss or when you roll a normal dice, what is the probability that you will get a number less than 7? That is 1 or 100%. Now, 1 in probability is called 100% in percentage. Because all numbers are below 7. So probability of that to happen is sure or certain. But if the question is asking what is the probability of getting more than 7 when you roll a dice, normal dice, that is impossible to happen. So 0 is the probability. Hope all of you understood. So if probability of something is below half, that is called unlikely event. If it is above half, that is called likely event. Above half means the chance that it will happen is more than the chance that it will not happen. For example, yeah, let me tell you one thing. Probability, some people think that probability of something happen means like I will tell this with an example of this cricket. Those of you follow cricket. In some matches or in most of the matches they will show the win probability. Na? Win probability means that is based on the opinion of the viewers. But sometimes the win probability you can see 95% chance is that this team will win. But actually the other team is winning. An exceptional performance by a particular batsman or bowler turned the game and the 5% chance team is winning. So what I am trying to say is probability of something is 1 means it will surely happen. If it is anything below 1, that means it is not sure. There is still chances that it will not happen. So this idea is actually tested in a previous GATE exam question also. If time allows, I will come to that question also. Otherwise, in our previous lectures, we have already discussed that. Go through that. You will be able to see those questions where this idea is checked, whether you understood probability correctly or not. Okay, now so this probability line is also clear. Now some types of events we will discuss very fast. Intersection events. Intersection event means this and that happening. For example, getting both heads when you toss two coins. There what you are doing, getting head in first event or first dice, getting head in second dice. So getting head and getting head. And means multiplication, I told you. So intersection means multiplication. So getting head probability, if it is half, and getting head probability half into half, 1/4 will be the probability. So this intersection event, again you can connect it with fundamental principle of counting itself. Similarly, union events is also there. Yeah, just like in set theory we say union, probability also we can say union events will be there. This or that to happen. For example, in this class I am choosing tea lovers, coffee lovers. If I ask you, if I choose a random person, what is the probability that he or she will be a tea lover or coffee lover? Tea lover or coffee lover means tea lover also we need, coffee lover also we need, tea and coffee loving people also we need. So what I am trying to say is the events can be union events also, where we need to find the probability of that. How to find the probability of that, I will come to that. So intersection event, union events, there actually, yeah, this I will explain with an example, that will be better. We will go to the next one, complement events. Union events, I will explain with an example, that time you will understand. Complement event, I already told you. So complement event means probability of something not happening. Like probability of getting a head is half. What is the probability of not getting a head? Or not getting head is called complement of getting head, or that is called complement events. Getting head and not getting head are complement to each other. That are complement events. Or we can say those two events added, you will get total probability 1, because either you will get a head or not get a head. So probability of those two added will be 1 now. Or by rearranging that, we can say probability of something not happening is 1 minus probability of that thing happening. That is what I tried to show you in that previous example. At least one head. The easy way to do that is find no head and subtract it from total 1 probability. That will be easy to solve. And another type of event is equally likely events. Equally likely events, again this also we will discuss with examples. Now another important thing is dependent and independent events. This I will elaborate little bit more. Dependent events and independent events. What is dependent events and independent events? For example, in a box there is 3 red ball and 3 blue ball. Questions are also asked in this format itself. In a box you have this many balls of this color, this many balls of that color. You are choosing randomly 2 balls. What is the probability that both will be of the same color or both will be of different color? These all are different types of problems that can be asked. So there actually dependency and independency can matter. I will tell you how it is. This thing actually permutation combination chapter also, this idea is needed in some questions. So dependent and independent event means, for example, if the question says what is the probability that both are red, if you replace the balls, if you replace the ball means you are picking 2 balls randomly, what is the probability that both will be red? If it is with the replacement. With the replacement means you pick a ball, you replace the ball and you again pick the ball. That means probability I told you, required outcome by total outcome. First one to be red, 3 is the outcomes where you get red ball out of 6 balls, so 3 by 6. Now second one red, what is the chance of that? If you replace the ball you took, there are 3 red balls again, still there are 3 red balls out of 6 balls, so that is 3 out of 6 itself. Now these two should simultaneously happen. First you get a red and again you get a red. The probability of that will be 3 by 6 into 3 by 6. All of you understood why it is 3 by 6 into 3 by 6? Because fundamental principle of counting, multiplication rule. If this happens and this happens, both these things together happens will be 3 by 6 into 3 by 6. All of you are understanding? So that is independent events. Why it is independent? The probability of the first event is not affecting the probability of second event. What was the first event there? Getting a red ball. What was the second event there? Getting a red ball again for the second take. Second ball probability is not affected by first ball in this case because you are replacing the ball. That is why the box always have the same number of red ball and blue ball. But if the question says without replacement, then you are picking a ball and you are not putting it back, you are again picking the second ball. In that case, what will happen? 3 red ball are there out of total 6 balls, so 3 out of 6 will be the probability of that. Then when you are taking the second ball, that red ball that you have taken is missing there. So there is only 5 balls remaining, and out of that only 2 of them are red because 1 red ball is missing now. So 2 out of 5. So the probability of that will be 3 by 6 into 2 by 5 using fundamental principle of counting, multiplication rule. Here it is dependent or not independent because second probability is affected by the first probability. As the first one was red, that is why 1 red is reduced. That is why the required outcome number is reduced and total outcome number is reduced. Did you all understood dependent and independent event differences? Dependent and independent event. Now many people misunderstand dependent independent with mutually exclusive events. They are not same. Mutually exclusive is something different. Replacement means the ball that is taken is returned back, Suvarna. That is the meaning of replacement. So mutually exclusive is something different. For example, when you roll a dice, the occurrence of even number and odd number are mutually exclusive. What does that mean? If even number occur, odd number cannot occur because no even number is an odd number, and vice versa. But odd number and less than 4, they are not mutually exclusive because for example, if the question is asking what is the probability that it will be an odd number or it is less than 4, there odd number, there are some odd numbers which are less than 4 also. Odd number 1, 2, 3, 4, 5, 6, what are the odd numbers? 1, 3 and 5. 3 odd numbers are there. Less than 4, what are the numbers? 1, 2, 3. So there, but this 1 and 3 are actually in both the sets. Below 4 also set it is there and odd number set also it is there. That means it is not mutually exclusive. There are intersection. In Venn diagram case, if we say there will be intersection, that is called not mutually exclusive. Mutually exclusive means there is no intersection at all. If even number occur, odd number cannot occur in the same event. So mutually exclusive simply means cannot occur together. Independent means not related. Okay, so now I will show you with 1 or 2 questions. I will explain more ideas. This is a September 2022 NET exam problem. NET exam, GEAT exam, this chapter is very important. Yeah, almost all competitive exam, this chapter is very important. All of you try this. And if you are feeling this session is useful, do hit the like button. That will encourage us to give more quality content in the future, and that will encourage YouTube to suggest this video to more people. And all of you, please try to share this video to maximum people because this is a common topic needed for almost all competitive exams. And many people are afraid of this topic also. In short time, I tried to convey maximum things that that will make the learning of this chapter easy. Okay, some of you already got an answer, very good. A fair cubic die is rolled 5 times and we get the face with the number 1 all 5 times on top. This is where I told you probability you should understand properly. 1 you are getting 5 times, 1, 1, 1, 1, 1. Now the question is asking 6th time what is the chance of 1 to occur. Now you may think 5 times 1 occurred, so the 6th time 1 should occur for sure, or there is a higher chance for 1 to occur. Is that correct? No, there is no higher chance because it is a fair die. Fair die means it is not biased towards any die or any side. It is unbiased. Unbiased and fair means the same. Means all sides have equal chance to occur. All sides have equal chance to occur. That is called unbiased or fair. Unbiased or fair. Then how 1 occurred 5 times? That is just coincidence. Because the die or the coin does not remember what occurred. No? But sometimes we think otherwise. We think that first time head occurred, so next time tail will occur. There is nothing like that. It is random probability. So anyway, so here first 5 times 1 occurred, that is just a dummy data. Question is only asking same phase means what is a probability of getting 1 on the 6th trial. 1 is just 1 out of 6 occurrences. Na? Required outcome 1. 1 means number of times 1 is there is 1. Out of total 6 sites. 1, 2, 3, 4, 5, 6. That is 1 out of 6. So option B is the answer. All of you understood this? Very simple, na? The same idea was asked multiple times. December 2018 also same question was there. Look at this one. Instead of dice it is coins. 5 times independently tossed. Independently tossed means that first toss will not affect the result of second toss or any other tosses. So yeah, that is a good point, Kripavaram. How much we try, the dice will not be fair because humans or even machines, if it try to create also, there can be slight imbalance that it is biased towards one side. That is possible. But we can think about an ideal situation. Yeah, no engine is ideal, but still we consider 100% efficient cases also. Na? Same way here, when the question says unbiased or fair, you can imagine it is an ideal situation where it will not be biased towards any side. So anyway, 6 unbiased tiles, 5 are independently tossed, all results in head. So 6th is now independently tossed. 6th toss is independent. That means probability of getting head is just 1 out of 2 now, because normally for a random trial, head occurrence will be 1 out of 2 chance, because 2 sides are there, 1 side is head. So 1 out of 2, so option C is the answer. All of you understood? Same question was repeated in June 2023. Yeah, this is a little different question. Try this. Very interesting one. June 2023 NET exam problem. Some of you got an answer. 3 fair cubical dice are thrown. Three dice are thrown simultaneously. What is the probability that all the dice read the same? Read the same means, what does that mean? Either all 3 are 1, or all 3 are 2, or all 3 are 3, or all 3 are 4, or all 3 are 5, or all 3 are 6. That means we need all these probabilities. Some people make a mistake thinking that only one of these cases are possible. No, all these 6 are okay. So probability of this is called narrowing down events. Here the event is saying all dice read the same. So that can be narrowed down to probability of 1, 1, 1, probability of 2, 2, 2, probability of 3, 3, 3, probability of 4, 4, 4, probability of 5, 5, 5. This or this or this or this or this. Or means either this or this. We don't want both. I mean, it is not like only one of this is possible. All these 5 are okay for the dice to read the same. Or means addition. So you can find this probability and add all that. I will tell you a shortcut for this also. What is the probability of getting a 1 when you roll a random dice? 1 by 6. Na? Second one, 1 by 6 itself. Third one, 1 by 6 itself. So all these ones to occur together, 1 by 6 into 1 by 6 into 1 by 6. Same way this will also be, or 1 by 6 into 1 by 6 into 1 by 6 is 1 by 216. Same way this will also be 1 by 216. Now this also will be dicto. This will be also same, this will be also same, this will be also same. That means 1 by 216 plus 1 by 216 6 times, or 6 times 1 by 216. 6 times 1 by 216, that is 1 by 36. This is how to use fundamental principle of counting when you do probability question. Now I will tell you a shortcut method. You don't need to write all these steps. What is a shortcut? Listen carefully. Due to lack of time, I will start explain it very fast. Another way of looking at this question is, listen very carefully. This is different from what we discussed just now. So for the first dice, what all are acceptable for us? Any 6 out of 6 occurrences are okay for us. If you get a 1 also, 2 also, 3 also, 4 also, 5 also, 6 also, in the first case it is okay, totally okay. Just like anagram problems in permutation combination, how we use logic, same way here we are doing this. This is a shortcut approach. So 6 occurrences are okay out of total 6 occurrences. So 6 out of 6 okay for the first event or first rolling of dice. Now for the second rolling of dice, only 1 out of 6 events are okay for us, because whichever number we got here, if you got 1, you can only get 1 again. If you got 2, you can only get 2 again. So whatever occurrence is occurring here, that only can occur here. That is why 1 out of 6. Again, compare it with permutation combination chapter I taught you. Same way the third occurrence also should be 1 out of 6, because whatever occurred here and here, that same occurrence should occur here. So that for that 6 out of 6 only 1 chance is there. Now all these 3 things should happen together, because first outcome, second outcome, third outcome, all the 3 should read the same. So 6 by 6 into 1 by 6 into 1 by 6, 1 by 36. This is the more holistic approach of doing questions. This idea can be used in most questions, and complement idea I taught you can also be used. So using these ideas you can do most of the questions. I know in short time I was trying to convey more ideas. Hope you got a basic idea about these things. These are few more questions for you to try. You can screenshot this and try this also in the latest question papers. Otherwise, in our playlist you can see more questions on these. Probability questions of last year are included in the June 2023 and September 2022 playlist. And more questions on probability chapter are included in GATE playlist also, GATE 2024 General Aptitude. There you can find more questions on this. So refer this playlist, and refer these 2 playlists for seeing more questions on this chapter. Through that you can learn more. The basic theory of probability we have discussed. Hope you got a clarity. Do let us know whether you felt this session was useful, whether the probability was made simple for you. So basic ideas in short time, try to convey maximum. So that's it. Let's conclude here. Thank you all of you. Take care all of you. Refer the remaining the other playlist also for extra learning. Thank you. Take care. Bye bye. Have a good night.